Why hello there, my distinguished individuals. Would you like to learn about the bird family tree? What am I saying? Of course you do. You clicked on this video and I'm excited that you have. I personally think that there is a lot of value in getting to learn about what the evolutionary tree of life looks like. It unveils a lot of cool evolutionary processes, and it lets you see some common traits of organisms and lets you see what about them has remained the same over millions of years and what's changed. There is a lot of value in biology in learning how organisms are related to each other, and I think that this video will hopefully provide some really good, useful information to you, specifically in how birds are related to each other, because I think you're going to find that there's a whole bunch of birds that are close relatives that you never knew were, and that there's a whole bunch of birds that you would have thought were closely related that actually aren't. So hopefully this will be an entertaining and educational video for you all. And one quick note before we begin here, if you are not quite sure about the idea of evolution and whether or not it's a real process, I'm not going to argue for that here. This is not the space or video to do that, but I will put some links down there in the doobly-doo about some really good videos that I think explain the process very well and show you why, not only that it's something that I definitely think is real, but also like why it's cool. I think it's just a cool thing to learn about. But anyways, enough preamble. Let us begin. But before we really get into it, we need to cover how to read a phylogenetic tree. A phylogenetic tree is just the scientific word for family tree. It's a scientific diagram that shows how different species are related to each other. We will be using the term phylogenetic tree for the rest of this video probably. Phylogenetic trees, like the one shown here, are the way that we show how organisms are related to each other. So things I want to point out on this diagram real quick. One of the main things is where all these branches split off from each other. The center of each branch is called a node, and branches come off from nodes. Nodes represent the last common ancestor of the different lineages that come out of that node. Especially when the ancestor is very deep, you'll notice that there are many nodes above it where the branches are all splitting off. Especially if we're talking about very large groups that have been around for a while, there'll be many, many nodes, right, of all the different lineages inside those big groups as they split off and speciate from each other. And each one of these has little organisms at the top of it. Note how you read the relatedness between the organisms is following each one of these lines down to where they connect at a node again. You do not look at the top of the tree. That's a very common mistake a lot of people make. The order that they're in up there means nothing. They could be arranged in a whole bunch of different ways. It's the branches that lead from where they're organized at the top or the side. Sometimes you see trees organized with them on the side. It's where those branches lead and where they connect to that shows relatedness. That's another key thing, is some people think that like this is kind of set in stone. Every single node can rotate the other way. I don't have a mobile with me, but often thinking of a mobile, like, you know, the things that you give for babies that rotate. You can rotate the same mobile in a whole bunch of different directions so that the things hanging from it are in different positions relative to each other. That's what you're doing with a tree when you're rotating the nodes. But it's the same mobile, right? You're not breaking it, you're not changing everything. That's the same thing that happens with these trees. I want to point that out because that's a key thing that messes people up. The other key thing that sometimes messes people up is how related organisms are is when they last shared a common ancestor. The more recently two species shared a common ancestor, the more related they are. In a similar way that you're more closely related to your siblings and parents than you are to your distant relatives, because you share a more recent common ancestor. I have seen people look at a tree like this and will make the case from it that mammals are of equal relatedness to amphibians as they are to lizards, when that is not the case at all. If you look at the tree, you'll notice that the mammals and the lizards combine at the node, right? You follow the branches down to their node. Their node is higher, more recent in time, than the node between both of them is and the amphibians. So mammals and lizards are more closely related to each other than either of them are to amphibians. Furthermore, it is also a mistake some people make to want to say that amphibians are more closely related to mammals than they are to lizards, which is also not the case. Amphibians are actually of equal relatedness to both mammals and lizards. They are not more closely related to either of them. And the reason why is because when you follow the branches down, they combine at the common ancestor at the same point. The common ancestor of lizards and mammals broke off at the same time that the amphibian ancestor broke off, meaning that they are actually of equal relatedness to both mammals and lizards. There's certainly some more in the weed stuff you could go with, but that's definitely the basics of how to read a phylogenetic tree, and it's going to be very important for the rest of this video. The last thing I want to point out with a phylogenetic tree is sometimes you'll see them and they look like this. What, you got multiple branches coming off of a node, or in this case this bar kind of represents this node. Like, what does that mean? That is used to represent when we don't know the relationships between these groups. We don't know which one of these four groups you see here is more closely related to the other one. When we have multiple branches coming off, that's called a polytomy. And that again is how we represent uncertainty in our trees, when we don't really know exactly how these groups are related to each other. But anyways, that's a lot of the basics of how to read a phylogenetic tree that I just wanted to establish real quick, because that's going to be very important for understanding some of the things I will say later in this video. So the first group of birds to break off from all the rest is a group called the Paleognaths. Paleognath means old jaw. I wonder why. Well, the reason why is because most birds possess a very specialized upper jaw apparatus. This specialization allows their upper bill to move independently of the rest of their skull. Kind of like this. So this is a trait that is common among most bird species, but the Paleognaths do not have this. They have a upper beak that is completely inflexible with the rest of their head. It's very stiff, kind of like how it is with most animals. Thus, old jaw, thus Paleognath. The Paleognaths today are the least diverse group of birds. Most of them are large and flightless, though it actually seems like this might have evolved independently in all of them, which is kind of wild. The only ones that can still fly are the South American tinamous, but not many people know about tinamous. The most famous representatives of the Paleognath group are the ostriches, the emus, the cassowaries, the rhea, and the kiwis. So what these birds lack in species diversity, they definitely make up for in charisma. Most of these are very well known, popular species that you ask anyone on the street and they'll probably know what they are. These guys split off from the rest of birds actually before the extinction of the dinosaurs. Based on genetic work, we know that they split off before the asteroid actually impacted the Earth. So the ancestor of them made it through the extinction event, which is pretty cool. And one last thing before we move on, another common feature among most Paleognaths that distinguishes them from other birds, in addition to their immobile jaw, is the fact that in most species, the female only actually lays the eggs and then she leaves the male to incubate the nest and rear the young. The only two exceptions to that are ostriches and great spotted kiwi. They are the only two Paleognath species where the female actually does help contribute to parental care. Continuing up the tree, the next group of birds that we have is the Galloanseres. The Galloanseres are then themselves split into two distinct lineages, the waterfowl and the upland birds, or the upland game birds, depending on exactly what terminology you want to use. The waterfowl, of course, include ducks, but also swans and geese, as well as these weird-looking things from South America called screamers, which don't really look that much like a duck or a goose and kind of look more like a chicken or an upland bird, which lets us know that the upland bird body plan is probably what was ancestral to this group, and then the waterfowl evolved out of that. But speaking of upland birds, that of course is the other group, and this includes stuff like chickens, turkeys, peacocks, pheasants, quail, all of the chicken-like ground bird living species. Both of these lineages have been far more successful than the Paleognaths, with both the waterfowl and the upland birds both possessing well over 100 species. It should also be noted that the Galloanseres actually also broke off before the extinction of the dinosaurs, so this was yet another group of birds that made it through the extinction event. So that's the Galloanseres. Very cool group, another group of very iconic birds. But now we get to a very interesting spot in the phylogeny, and that is the Neoaves. The Neoaves are all the rest of birds. And so the Neoave group contains like 10,000 species. If you couldn't guess by the fact that the Galloanseres split off before the extinction of the dinosaurs, the Neoaves also split off before the extinction of the dinosaurs. Only except after the dinosaurs went extinct, they exploded in diversity in something called an evolutionary radiation. An evolutionary radiation is when a species or a group of species find themselves in an environment where there's a whole bunch of open niches. Typically after a mass extinction, when a whole bunch of niches have opened up, or when a species gets to an island and there's a whole bunch of niches available just because there's no organisms filling that. Because there's no other organisms filling these niches and competing with this new species that got there, they can expand in diversity to fill all these new niches that they never could before. And that's exactly what happened with the Neoaves. They very quickly diversified into a whole bunch of different niches, and they did it very fast. So fast that it's very difficult to figure out which one of their major lineages is more closely related to the other ones. So as a result, we will be reconstructing all 9 of their major lineages as a polytomy. Since we're sure that all the members in each one of these 9 lineages are each other's closest relatives, we're not too sure how they all relate to each other. And in traditional phylogenetic fashion, we will be covering them in order of the group that contains the least amount of families to the group that contains the most amount of families. The first group, I believe, is pronounced the Opisthocomiformes, and it in the modern day is represented by not just one family, but only one species. This is the Hoatzin of South America, which, as you can clearly see, is a very strange looking bird. Probably most famous for the fact that the babies actually have claws on their hands that they'll use to climb back into trees when they fall out of the nest. Very strange and a very unique bird, and again, the only representative of its family. It's been on its own evolutionary trajectory from all other birds for like 65 million years. Wild. The next major lineage is the Mirandornithes. This group contains only 2 families, the grebes and the flamingos. Grebes are birds that are sometimes mistaken for ducks, but are not ducks. They are in fact their own thing, and one of the ways that you can tell is they don't have a duck-like bill, and another way is they don't actually have webbed feet. They have lobed feet that they use to swim. Lobed feet basically just means that they have very wide toes. And their closest relatives are of course the tall pink birds that so many of us have come to love. I bet you weren't thinking that they were each other's closest relatives. I bet you would have thought flamingos were more closely related to like cranes or herons. But despite the fact that they might look more similar to cranes and herons, the latest studies have been showing that they are part of their own distinct group of birds with the grebes, which is pretty cool. The most famous family in this lineage is the Columbiformes, otherwise known as the pigeons and doves. Everyone loves pigeons and doves, but what you might not know about, but should love equally, are the sand grouse and the mesites, which are the other 2 families in the Columbomorphae. Despite being called sand grouse, and they do kind of look like grouse, they are more closely related to pigeons, and they live in the deserts of the Old World. Meanwhile, the mesites are only found on the island of Madagascar. After the Columbomorphae, we have the Otidomorphae, which, like the Columbomorphae, contains 3 families. The cuckoos, which include birds like the common cuckoo of Europe, but also some unexpected ones like the greater roadrunner. The bustards, which is an old world lineage of birds that are fairly large and kind of turkey-like. And then the turacos, which is a group of mostly colorful, with some exceptions, group of tropical birds. Next up we have the Strizores, which I think I'm pronouncing correctly, but they contain a bunch of nocturnal insect eaters, like nightjars and frogmouse and potos. Legends, all of them. They just are a whole group of nocturnal insect eaters. Except for 2 different groups, the swifts and the hummingbirds. That's right, swifts and hummingbirds are related to nightjars and frogmouse. I'm assuming everyone knows what a hummingbird is, but for those who might not know, swifts are these very small aerial insectivores. But they're really cool because they actually spend most of their lives on the wing. In fact, they only land to nest and raise young. They even sleep in the air. Wild. But the really colorful, charismatic, nectar-eating hummingbirds are related to nightjars? That seems pretty crazy, but again, it's what all the phylogenetic studies show. And there are some common features among them, such as their really short feet. And if you look at swift wings and hummingbird wings, they actually look pretty similar. In fact, if you ignore their weird flight style, hummingbirds actually look way more like small, colorful nightjars or swifts with long beaks than you might think. But furthermore, all of these cryptic brown nocturnal insect eaters are all near the base of the Strizores tree, whereas hummingbirds and swifts are up more near the top. That means it's incredibly likely that hummingbirds and swifts evolved from a form that looked like a nightjar or a frogmouth. It wasn't a nightjar or a frogmouth, but it would have looked like that, which is one of my favorite evolutionary facts. It's wild. It's crazy to think about these small, colorful little birds evolving out of this, and something that we wouldn't know if we didn't know the shape of the phylogeny. Again, showing the value that there is in conducting these studies and learning how these organisms are related to each other. After them, we have the Gruiformes. The most famous of them are probably the cranes. Everyone loves cranes, but do you know what cranes are closely related to? Rails. Rails are these small cryptic marsh birds, and now that you know what they look like, when you compare them to a crane, cranes kind of just look like stretched out rails, and that's kind of because they are. They're just rails that have evolved to be very tall so they could wade into deeper water. But they're not the only two groups in the Gruiformes. There's also the coots, which are actually in the same family as rails, but they're often not referred to as rails, as well as things like the limpkin of the Americas and flufftails. So all of these lineages have been pretty small in overall diversity so far, but we're about to get into the three major lineages of the Neoaves. First up, the Charadriiformes. These guys can typically be referred to as shorebirds. And this name is very fitting considering that most of them do stuff along the shore. It contains groups such as sandpipers and plovers, as well as things like oyster catchers and stilts and jacanas and snipe. Snipe are real, they're not just from up, but they don't look like they do from up. Very sad. Given the commonality of this basic sandpipery body plan, it's very likely that this is the ancestral form of the group, but there are some members that have decided to change that quite a bit, such as the button quail, which are not actually at all closely related to actual quail. They in fact are a group of shorebirds that have evolved to look and act like quail. That's crazy, and not only that, seagulls are also Charadriiformes, as well as alcids, which are basically like the northern hemisphere version of penguins. Things like puffins and auks are alcids. They're also Charadriiformes. They're in this shorebird group. They would have evolved out of a sandpipery body plan. Charadriiformes, especially sandpipers, are also famous for having a wide variety of different mating systems. These guys do it all. They do a lot of crazy stuff. But we don't have time to talk about that in this video. If you want to learn more about mating systems, then check out this other video that I made, link in the doobly-doo below. Next up, we have the Phylogenetic, which I think I'm pronouncing right, but I'm not sure. Like the Charadriiformes, this lineage is very, very speciose and has lots of families in it. But one thing that is common among most of them, but not all of them, is that they typically are associated with water in some way. Very low on the tree, we have things like the cagou and the sunbittern, which are kind of their own weird little things, but also things like tropic birds and loons. And loons are also not ducks for anyone who is wondering. The duck-like body plan of loons and all other water birds is due to convergent evolution. It's the same reason why like cranes and flamingos and herons all have a similar body plan. Convergent evolution is when two different lineages of organisms independently evolve similar traits because they fill similar niches in the environment or have a similar lifestyle. The reason why grebes, loons, and coots all look a lot like ducks is just because that body plan is very efficient if you want to be a bird swimming around in the water. So whenever a bird evolves to swimming around in the water, they evolve a body plan that kind of looks like that. Same thing with flamingos, cranes, and herons. If you want to be a bird that's wading around in deep water or tall grass, it makes sense to have long legs and a long neck. If you haven't gotten the gist of it by now, convergent evolution is very common in birds and is the primary mechanism that some people can get how these families are related to each other makes mixed up because birds that aren't closely related to each other can sometimes evolve similar traits. But I don't want to make you think that this lineage only contains loons and sunbitterns. It also contains a group called the Proceleromorpha. Again, I think I'm getting that right. But it contains penguins, the famous penguins, as well as birds like albatross and storm petrels. And regular petrels too. I don't know why I started with storm petrels. There's also a group called the Suliformes, which contains frigate birds, boobies, gannets, and cormorants. This major lineage also contains storks and a group called the Pelecanniformes, which contains herons, ibis, spoonbills, as well as, surprise, surprise, pelicans, and the legendary shoebill of Central Africa. So, for the astute of you that have been keeping track at home, that means that there's only one more major lineage of Neoaves left. You might also have noticed that we haven't talked about a lot of other bird groups that you know about yet. And that is because this last group of the Neoaves, the Telluraves, again, I think I'm pronouncing that right, but it's easily the biggest group of the 9 major groups of Neoaves. And it itself is divided into 2 major lineages, the Afroaves and the Australaves. The Afroaves means birds from Africa, and Australaves means birds from the south, but plenty of Australaves can be found in the north, and there's lots of Afroaves that are also not just found in Africa, so I don't really know where those terms came from. But those are the terms for those groups anyways. The Afroaves are then further subdivided into 4 major lineages themselves, which will also be represented as a polytomy because we're not 100% sure how they're related to each other. One of those lineages is the mouse birds, which is actually a group that's only found in Africa today, but we know from the fossil record that they were found in other places. They're small gray birds with long tails, look kind of mouse-like. Another one of those groups is the owls, the charismatic owls. People love them, creatures of the night. They've got enormous eyes, the ability to turn their head basically all the way around their body, and silent flight. People love owls for good reason. People also really just like birds of prey in general, most of which can be found in the Accipitromorpha. The Accipitromorpha contains the New World vultures, as well as your hawks, eagles, osprey, and secretary bird. Very, very cool group, but the last group of these Afroaves is the Cavitaves, named such because all of these species nest in cavities or burrows of some kind. They're not the only birds that nest in cavities or burrows of some kind, but that is a common feature of all members of this group. It contains a lot of different families, some of which you've probably heard of, such as toucans, woodpeckers, kingfishers, and hornbills, but also some groups that you might not have heard about, such as cuckoo rollers, actual rollers, toadies, yacamars, and motmots. I love motmots. I don't know what it is about motmots, but I just like motmots a lot. I love saying the word motmot. I'm going to say it again, motmot. Deal with it. Motmot. But that wraps up the Afroaves. Next up is the Australaves. The first group to branch off from the Australaves is the South American Seriamas, a group of terrestrial hunters that are the closest living relatives of the extinct terror birds, something I just feel people should know about. They've also got little raptor claws on their feet, which is also really cool. After the Seriamas is the falcons. Yeah, that's right, falcons aren't actually closely related to hawks and eagles. If you didn't think that, that's fine. Scientists didn't either until genetic analyses came out. Again, falcons just look like hawks and eagles through convergent evolution. If you want to be a predatory bird, having big talons on your feet and a short hooked bill is just they're 2 good features to have. But falcons are of course also distinct from hawks and eagles because they're also wicked fast. In fact, the peregrine falcon is the fastest land animal. I mean, it can't run that fast, but like it can fly that fast when it dives. After that, we have the parrots, which I don't really feel like I need to talk about too much. I assume most people know what parrots are. But then after parrots, we have the passerines. The passerines is the scientific family name for what a lot of people refer to as songbirds, though not all of them sing. That's why some other people refer to them as perching birds, but not all of them perch, because that's how evolution be sometimes. Plus, also, there's plenty of birds that perch that aren't passerines. Pigeons and doves aren't passerines and they perch, so I don't really think that's a good terminology, which is why we're going to call them passerines instead. But passerines is just one order of birds, but is easily the most successful of them all. In fact, half of all bird species are passerines. To say that passerines are successful would probably be an understatement. they are successful. And as a result, we're not going to be able to do their due diligence here. But we are certainly going to cover their major groups. The first group that breaks off is actually not very speciose today. It is the New Zealand wrens, which are not actually closely related to everything else that is called wrens, other than the fact that they are passerines like wrens. But all other passerines are more closely related to each other than they are to New Zealand wrens. But as their name suggests, they're only found on the islands of New Zealand, and they're very small and kind of poor flyers. In fact, they actually had some flightless species, but they went extinct when the Europeans arrived and introduced invasive predators. Next up, we have Tyranni. No, this group does not contain Tyrannosaurus rex, but it still has the same root word, tyrant, for the family names. And this is because that within the Tyranni is a family called the Tyrannidae, which are also known as the New World flycatchers. They were named this because the most famous members of them are the kingbirds, and the kingbirds are kind of tyrants to other birds. They're very aggressive and they chase them around, chase them off their nesting sites. But the tyrannids, the New World flycatchers, are actually the most speciose family of birds in the world. There's over 400 species of them. But they are not the only really speciose family in the Tyranni. There's also the antbirds and the ovenbirds, which also contain over 200 species. A very, very diverse family, mostly restricted to just South and Central America. And a lot of people haven't heard of these guys, even though they make up a lot of the world's bird diversity. But to name a couple other cool members before we move on, it also contains the cock of the rock, as well as the umbrella birds and the famous dancing mannequins. After that, we've got a couple stray lineages of passerines, such as the really big for passerines lyrebirds of Australia, which are also really fantastic mimics, as well as the really pretty fairy wrens and the bowerbirds, which are famous for building really crazy structures in their mating displays. But after all these stray lineages, we have another major lineage of passerines, the corvides, I think is how it might be pronounced. I've heard it referred to sometimes as the corvoids. But this is another major group that mostly contains bird species that are found in the Old World, especially around Australia and Australasia. But it includes things such as the citellas, the wood swallows, the butcher birds of Australia, which includes the Australian magpie. And these butcher birds are not closely related to the shrikes, which are also sometimes called butcher birds, but they are still corvides. They're just not super close in the corvide group. Shrikes are pretty closely related to crows and ravens, as well as jays though. And this group also contains members such as the Old World orioles, the monarch flycatchers, the durongos, and the legendary birds of paradise. After the corvides, we come to a group called the Sylvida. This group contains the famous chickadees as well as tits. It also contains larks and swallows and a whole variety of Old World warbler species. After that, we have the group Musicipita. This group contains many Northern Hemisphere passerines, such as kinglets and nuthatches and creepers and wrens and thrushes and dippers, as well as waxwings. And of course the Old World flycatchers, we can't forget about those. They're a very diverse group and include the European robin. And after that, we have arrived to the last big group of passerines, the Passeridae, which contains the species that the group is known for, the house sparrow. The scientific name of the house sparrow is Passer domesticus, and passer is where the term passerine comes from. So, perhaps spoiling it, this group does contain the Old World sparrows, which the house sparrow is a part of. But it also, of course, contains much more than that. It also contains the indigo birds and the finches, and the New World sparrows, and the New World warblers, and the blackbirds, and the yellow-breasted chat, and the cardinals, and the longspurs, and a bunch of other families that unfortunately we don't have the time to really go into detail with. But there you go! That's the bird phylogeny, and now you know. Certainly there's more detail that can be gone into this. We did not go into this phylogeny at a family-by-family level. We just covered all the highlights here, but this could potentially open up the avenue for you to do some of your own research if you want. And if not, I hope that you at least found this very entertaining and enjoyed learning about the broad strokes of the bird family tree. I hope that you enjoyed this video. I enjoyed making it, and I do hope to post more educational videos like this in the future. But anyways, that's it for now. Y'all have a great rest of your day.